Welcome to my video lecture on testing the population proportion when p hat is not given and only an x and an n has been provided for you. Let's look at a problem here. In a clinical study of an allergy drug, 108 of the 202 subjects reported experiencing significant relief from their symptoms. At a 0.01 significance level, tester claimed that more than half of those using the drug experienced relief. Now, the claim is that more than half experienced relief, so if I try to write my claim, more than half experienced relief, when talking about half of a population, you're talking about a percentage, so this is obviously a percentage hypothesis test. So it says more than half. Test the claim that more than half, that means greater than half. We're not going to write 1/2 because we want to use decimals in this topic. So more than half would translate to greater than 0.5. And that would be my original claim. My counterclaim, the opposing statement, would be the counter statement here, which will be less than or equal to 0.5. But remember, as I've told you here, when you set up your null and alternative hypotheses, the equality always goes to the null hypothesis, and only the equality part survives and stays because you only need a single value in the null hypothesis to trace. So you don't need to write the rest of it. One of the claim or counterclaim when they're set up in the null and alternative hypothesis level, one of the null hypothesis always has to be the equal sign, as you've been told. Then we write the information here. X is 108. Of course, p hat's not given to you, so we're going to have to find it. N is 202. Your significance level is 0.01 alpha. And we're trying to test the claim with that significance level. Well, I usually call this step 0 because that's where we write the given information in the exercise. Now, my null and alternative hypotheses will be easy to write. I'll start with the one that doesn't have an equal sign next to it. I always start with that, and I give that to the alternative, so p greater than 0.5. And that's my original claim. And the counterclaim in this case will go to the null hypotheses, and only the equal part has to be written. You don't need to worry about the other part. The test handles that, and that's your counterclaim. So there is my step 1. Okay, now the second step of a hypothesis testing procedure, again, is to find that numerical value you need to use to determine if you're going to fall in the rejection region or not. Now here again it's a test of p, so my critical value, my test statistics will be calculated using p hat minus p over the square root of pq over n. Now in the previous example I'd done, p hat was given, so I basically wrote what p hat was. Here p hat's not given, but I have x and n, so here I can find my p hat by dividing x by n. 108 divided by 202, and if I write 3 decimal places, I get 0.535. And since you're doing this on a spreadsheet, you don't have to worry about how many decimal places to carry, because you can just click on p hat if you need to use it in a formula. So that's my p hat. My p is 0.5, so my q is 0.5, and my n is 202. So at this point, I can simply just plug these in. 0.535 minus 0.5 divided by square root of 0.5 times 0.5 divided by 202. And if I calculate that out, I get 0.985, almost a 1. And that becomes my test statistics. Very good. So let me just erase that, because you could always rewind it and watch it. So the answer is 0.985, so I don't need to write all that. I can just grab this. There we go. So that's my step 2 in the hypothesis testing procedure. Very good. Now my third step is to actually, again, construct that very good rejection region. So let's see what you need to decide if it's going to be a 1-tail or a 2-tail rejection region. Well, in this case, and remember for that, we always look at Very good. We always look at the sign of the alternative hypotheses. If it's pointing to the right, then it's a right tail. If it's pointing to the left, it's a left tail. If it's a not equal to, then it's a two tail. In this case, it's pointing to the right. So I'm going to have a right tail rejection region, also known as a one tail test. That means all of alpha goes in that tail. So if I were to put the alpha in there, given it's 0.01, then this area here is 0.01, the yellow area. Now some people are wondering why they're giving you that 0.01. Well, if they didn't give you that 0.01, how are you going to find this value here? Because in order to find this z value here, because remember it's the z-axis, in order for you to find that z value, you need to know how much area is here. And somehow they either have to give you that area, or they have to give you something else so you could then find that from it. So that's why they have to provide you with that 0.01. Otherwise, how would you have known what the question mark area is? And why do you need the question mark area? Well, you need the question mark area to find this number. Remember, in order to read a z value, you need to know the area to its left. So if this is 0.01, how much area is to the left will be 0.99, correct? That's right, so that's what you would use when you type norm.s.inverse, and then you write 0.99 here, and that would give you the critical value you're looking for. And if I erase these so I could write what it is, okay, I'm good with all that. Okay, so my critical value, if you type that command, you'll get 2.326. And that is my official third step of a hypothesis testing procedure. Very good. Now my fourth step would be to draw a decision and then come up with a conclusion for that decision. Now the decision has to do with this test statistics and whether it lies in this non-rejection region or it lies in the rejection region. That's the question. Now if you remember, the middle is 0, so again I'll draw the number line here on the side. If that's 0 and this is 2.326 and this is the z-axis, whereas 0.9, well 0.9 will be somewhere there, so therefore it's outside the rejection region, so it's somewhere there, so therefore we can reject the null hypotheses. You can only reject the null hypotheses if the test statistics falls in the rejection region. So here you have to say I fail to reject the null hypotheses because my test statistics falls in the fail to reject or the acceptance region. So your decision here is to, let me change colors, is to fail to reject the null hypotheses. So you're failing to reject the null hypotheses, but since the null hypothesis here is the counterclaim in our exercise, and the actual claim is categorized under the alternative hypotheses, if I'm failing to reject the null hypothesis, that means the null hypothesis is probably true, and since my claim is the contradictory statement, then my claim is possibly false. But you don't write the claim is possibly false. You say there is sufficient evidence to reject the original claim. That's how you want to word it properly. There is sufficient evidence to reject the original claim. And that's what you write. And that's the proper language you use. So there is sufficient evidence or there isn't sufficient evidence to reject the original claim. And that'll be the end of the test. Let me show it to you typed up. So you notice I write the given information, I write the original claim and a counterclaim, then I categorize them under the null and the alternative hypotheses, then I do my step 1, step 2, step 3, and then basically look at this value and look at this value and find out if I'm here or I'm outside of it. In this case, I'm outside of it, so I fail to reject the null hypothesis, which means the null hypothesis is correct, which means this is not correct because those are opposite of each other. And if the original claim is being rejected, it means there is sufficient evidence to reject the original claim, and that's the language. You don't say the original claim is no good or the original claim is false. This is the proper language you use to declare your final conclusion. Thank you.